Hey there, and welcome. Today, we're going to pull back the curtain on one of the most important rules in all of science, Ohm's law. It's this super simple, really elegant equation that lets us get a handle on the totally invisible world of electricity. I mean, really think about that for a second. Electricity, it powers our entire world, but you can't see it, right? So how in the world do engineers and electricians actually work with it? How can they possibly know what it's going to do next? Well, that's the exact problem that Ohm's law comes in to solve. All right, so let's jump right in. To really get a grip on this law, you first have to meet the three main characters in this story, the invisible forces that are at the heart of any electrical circuit. Okay, first up, we've got voltage, which we measure in volts. The easiest way to think about it? It's the push. It's the electrical pressure coming from a power source, like a battery, that gets everything moving in the first place. It's the force that's trying to shove those electrons through the wire. Next on the list is current, and we measure that in amps. So if voltage is the push, then current is the flow. It's the actual measurement of how much stuff, how many electrons, are flowing past a single point at any given moment. It's the sheer volume of electricity on the move. And our third and final player is resistance, measured in, you guessed it, ohms. This is the squeeze. It's basically anything that gets in the way and slows that current down. It's a lot like friction, really. Some materials just make it way harder for electricity to get through. The best way to picture all this is with a simple garden hose. It's a perfect analogy. The voltage, that's the water pressure coming from the spigot. The current, that's the actual amount of water flowing out the end. And the resistance, well, that's you pinching the hose. The tighter you squeeze it, the harder it is for that water to get through. See? The push, the flow, and the squeeze. Simple as that. So, now we've met our three forces, but here's where the magic really happens. They aren't just three separate things doing their own thing. Nope, they're all connected by one incredibly simple yet super powerful relationship. And here it is. V equals I times R. That's it. That's Ohm's law. Voltage is just the current multiplied by the resistance. I know, it looks almost too simple, right? But believe me, this tiny little formula is the master key that unlocks how pretty much all circuits work. And that's its whole job, really. The whole point of Ohm's law is just to show us that direct, predictable relationship between these three things. It's the math that connects the push, the flow, and the squeeze. Okay, so theory is one thing, but let's see what this formula can actually do. Let's put it to the test with a real-world example and see how powerful it is when we plug in some actual numbers. All right, time to solve a little puzzle. Let's say you have a basic circuit. We know it has a 12-volt push and a 6-ohm squeeze. So the big question is, how much flow, how much current are we actually going to get out of it? Well, using our formula, this is super easy. Our goal is to find the correct, right? The letter I. To do that, we just have to rearrange the formula a little bit, so it becomes I equals V divided by R. Now we just plug in the numbers we know. That's 12 volts divided by 6 ohms. And what do we get? The answer is 2 amps. Boom! Just like that. We used the two things we knew to figure out the one thing we didn't. That right there is the power of Ohm's law. Okay, let's try another one. Let's flip it around this time. Say we know the flow is 3 amps and the squeeze is 5 ohms. So the question now is, how much push, how much voltage do we need to make that happen? Again, it's just a matter of following the formula. Our goal this time is to find the voltage, or V, so we can use the original formula just as it is. V equals I times R. Let's plug in our numbers. That's 3 amps times 5 ohms. And that gives us our answer, 15 volts. See how cool that is? It's so versatile. It literally doesn't matter which piece of the puzzle is missing. As long as you know any two, you can always find the third. So, okay, we can do the math. That's great. But why is this so important? Why does this one little rule matter so much in the real world? Let's break down the big takeaways then. First off, V equals I times R is basically the fundamental rulebook for all circuits, period. Second, it's like a magic puzzle. If you have two pieces, you can always find the third. And that makes it this incredible tool for predicting what's going to happen, which means we can design circuits that work and figure out why they don't. At the end of the day, it's the foundation for understanding absolutely everything electronic, from the phone in your pocket to the entire power grid. And that's exactly why this is so critical. I mean, if you're a student, an electrician, or even just someone tinkering with electronics in your garage, Ohm's law isn't just a nice to know, it's the first and most important tool you have. Which kind of leaves us with a pretty big thought, doesn't it? We just saw how one single simple formula can give us the power to predict and control this massive invisible force. It really makes you wonder, what other simple rules are out there quietly shaping our world, just waiting for us to find them?